Final presentation, my views about what it takes for successful exploration. Essentially, it's based on personal experience, and not all of my comments would be agreeable for some people, but these are my comments. So it's broken down as follows: a little bit about economic geologists, successful exploration teams, mentorship, health and safety, models, and some final remarks. Economic geologists are those that go out to explore and discover economic or mineral deposits that can be economically and responsibly mined for the benefit of society and also the shareholders, because it's the shareholders who put up the capital for the mining companies to be able to go out and explore. 95% of mineral exploration is done in the private sector. And to raise money for that, shareholders have to have a return on their investment. Otherwise, they could just put their money into real estate or another kind of investment. So that's the function basically of an economic geologist. However, for anyone that's been in this business as long as I have, you would know that it's a very, very high risk, tough business. And here's some of the statistics. This is actually from Rio Tinto. So if you had 1,000 good quality prospects, the chances of one of those becoming a profitable mine is 1 in 1,000. If it was going to be a world-class mine or a tier 1 deposit, your chances are 1 in 33,333. So it's very akin to gambling. The odds of success are totally against you. And unfortunately, most economic geologists devote a career. They do high quality work, but it's not everybody who gets to participate in an exploration success. Here's the challenge. So if we imagine a library room, and we're going to look for the gold deposit in the library, which is those yellow shelves, and we set up our drilling machine outside the library, we can't see inside, and we drill 5 holes. What are our chances of hitting those yellow shelves within the library? And it's only through drilling that most deposits are discovered. So this is a simple illustration of how difficult that can be. Here's a number of drill holes. These are sections. So we're looking at vertical sections, and we're looking at 4 holes here. So on the top left are the actual drill intercepts. That's the X meters at X grade. On the right, a conservative geologist's interpretation. So we start to think, well, how can we connect the dots? What this might be, what kind of ore body? A very optimistic geologist on the bottom left essentially joins all the dots, and our ore body looks like that. And on the bottom right, we have the geophysical interpretation, which generally creates a larger footprint than the mineralization. Then in reality, the mining engineer comes along and looks at the data, and the actual picture can change dramatically. And so there's basically the same intercepts, however, with a very different interpretation. Why are some people more successful than others? Is it serendipity? Is it extremely good planning? Or it's just meant to be? I personally think it's a number of these factors. So in my career, I've been involved with teams with good planning. That's led to some success, but there's definitely a luck factor involved. Some people are more successful than others. And here's 4 companies that all had serial success over a period of time. And this is broken down into both commodities and geographic locations. In all cases, each company had a very, very strong technical leader who had good support and well funded to do exploration according to a long-term plan. All of these gentlemen were really successful, some of them in different countries and different commodities, Others, such as Randgold on the bottom right, were clearly focused on gold, and they were focused in West Africa. Newcrest on the top right were mainly focused on copper gold in Southeast Asia, and they were very successful. Graham Brown on the bottom left with Anglo American had a license to look anywhere in the world for basically anything, and they found many different commodities in different countries. So breaking those down, this just summarizes those four companies, their number of discoveries, significant discoveries that became large mines, and the metals and commodities. The most successful explorer of modern times was Canadian entrepreneur Robert Friedland. And this particular table shows the number of, or the discoveries that were made and the commodities, and the asterisks show the discoveries that were what we would call virgin discoveries. In other words, there was no record of the metal that was found in the region. In the case of Voisey's Bay, that turned out to be a huge high-grade nickel, copper, cobalt, platinum mine. In the case of the Platte Reef in South Africa, this is the world's largest in construction PGE mine, and other examples shown there. Moniwa, when Ivanhoe went into Moniwa, it was quite a small deposit. There was a very large drilling campaign, and that would be called a brownfields discovery, where a large deposit was found around a relatively small one. The same thing happened at Oyu Tolgoi, as we discussed on Sunday, where a small deposit became the third largest gold copper porphyry in the world. So when you distill this down, 7 virgin discoveries, 11 metals in 10 countries. The stock market. I commented at the beginning that it's the shareholders who fund industry for mineralization, to discover mineralization and ore deposits. Unfortunately, the stock market is very cyclic, and that reflects cyclicity in metal prices. And it's not a straight line over periods of time. Metal prices fluctuate, and there are a number of reasons for this. It could be political, it could be technology, supply and demand of the metal. There's many reasons. Unfortunately, our industry is cyclic. We have the good times and the bad times. So the cyclicity. In the good cycles, it's possible for your geologic team to invite friends to go and have a nice lunch with a good bottle of wine. Perhaps you've bought a new car, you've made a lease on a boat, and you bought some nice real estate overlooking the Andaman Sea. That's the good times. For every good time, it's quickly followed by a bad time. And this is what we call the downturns, or the bottom of the cycle. We can no longer afford to go for a nice lunch. We've had to sell the car. We've stopped the lease on the boat, and we've now have modest real estate investment. That's how cyclic our industry is. By far the worst downtime or bad time in the cycle that I've experienced was in the period 2013, post the GFC, up until about the pandemic, to be honest. And we were just starting to recover from the pandemic, and then we were hit with, we're just starting to recover in the cycle, and then came the pandemic, which had a huge impact on mineral exploration. This graph reflects the cycle since about 1990, and in the blue part of the chart, these are the good times, and the red in the bottom of the chart show the bad times. And what this obviously shows that the cycles are increasing in periodicity. And we were just starting to come out of a bad cycle in 2015 when we were recovering. And then not long, a couple of years later, came the pandemic. So unfortunately, that had a big impact. This is a very interesting curve. It's known as the Lassonde curve, and it illustrates the life cycle of a mineral discovery. And it also shows the time frames of these cycles, which are shown in the bottom in the number of years. So at the beginning of a 5-year period, we have an exploration team on the ground. After 5 years, we've actually, it looks like we've made a good discovery. And so the value of that project goes up substantially, as does the share price. And that will continue to go up until a discovery value can be placed on it, i.e., how many possible tons in grade is it? And that's the top of the first part of the curve. Then there's another 2-3 years where there's no real news flow. Everything is about the feasibility study, engineering work, a lot more drilling, but no real excitement. So the share price goes down and the value goes down. Then once that feasibility study is bankable and financed, investors then realize that this really has an enormous value and it's going to generate a huge amount of cash. So there's the second part of the curve where investors will come in from a long-term point of view to develop while the deposit's being in production and paying dividends, and the share price will appreciate. And then finally, the end of that curve is the depletion of the ore body and mine closure. But if you look at the timeframes involved here, so from discovery, we've got 2 years, feasibility 3 years, another 2 years, and then probably 10 to 20 to 50 years. These are the cycles that are typical going from a mineral discovery to mine closure. This is a very, very well thought out cycle illustration, and it's very true to today. Every year in Vancouver, there is what's called the Sprott Conference. And this conference typically has 6,000 or 7,000 people, mostly investors, promoters, mining companies. And they have a forum. And in this forum, each one of these gentlemen independently founded a multi-billion-dollar company. This wasn't something that was a historic company. These gentlemen took a company from nothing to billions of dollars. And each one of them at this particular forum was asked, why were you so successful? And every single one of them said it wasn't really them. It was their ability to raise capital and give that to competent people or teams that they trusted to go out and use that capital to make discoveries. And that's what led to each one of these individuals' success. Multiple discoveries were made by the exploration teams of each of these gentlemen, and their common denominator was provide the funding and get the right people to do the exploration and make the discoveries. I have some comments about health and safety. So clearly the one on the left is a major industrial disaster somewhere in Yunnan. The one on the right is exploration program I was involved with in Mongolia. And clearly there's a very big difference between the regulations one would apply at an industrial site, such as a mine, and an exploration camp in a reconnaissance stage of prospecting and looking for a mineral deposit. The problem here is that most of the big companies apply the same health and safety standards to that around a mine, to that around an exploration camp. They're two very, very, very different things. It's impossible to apply rigid health and safety restrictions on an exploration team, because if you do that, they can't go anywhere and they'll never find anything. I've been a strong believer and still am that exploration, health and safety policies need to have input from a highly experienced exploration manager to ensure that the team is safe and healthy, but in a very practical manner. And sadly, in most big companies now today, common sense has completely disappeared, and we have all these health and safety restrictions that prevent the exploration team from working effectively and therefore limiting their ability to make discoveries. This is clearly reflected when you look at statistics in the declining rate of exploration discoveries in the last 20 years. Here's a nice example. This gentleman here, Slava, he was responsible for finding the bonanza grade epithermal silver gold deposit called Kupol in the Russian Far East. And I took one look at this and I thought I would hire this guy in a minute, because clearly he knows exactly what to do and he's well equipped to do so. And he was highly successful. Incidentally, earlier this year, I didn't know that he had a son who was a geologist, and his son actually saw this photo from a copy of my presentation, and he contacted me and he sent me a photo of his dad whilst he was doing this exploration work. So this is an even better photo, and he's clearly well equipped to do everything he wants to do. He's got his own self-sufficient camp, and the rifle is actually for bears. It's not for any defense purposes other than safety. And once again, I would hire this guy in a minute, but there's absolutely no way he could work for or be engaged by a major mining company today. I did show a few photos on Sunday about Ivanhoe's exploration, or then Indochina's exploration in Indonesia. And this was done because of the jungle terrain and lack of surface cover. A lot of this was done by traveling up rivers, prospecting and mapping. This program was done in conjunction with local people who are known as the Dayaks, and they knew exactly what was safe and what wasn't safe in their own backyard. And we relied on them, working in conjunction with them and doing our exploration. And we never had one major health and safety incident. Another aspect that is absolutely a no-no for successful exploration is for some people, a management in a head office, to micromanage the exploration team, meaning to say that they are dictating the concepts and the policies for the exploration team based on no real experience. Once again, it's the experienced exploration manager that knows what's required to be successful in a safe and healthy environment. I believe AI has a huge part to play in the future for analyzing data. However, having said that, it's only as good as the data that's inputted. It doesn't have the ability to think laterally or actually assess quality of data. So it's going to be increasingly important, but it's not a silver bullet. The HR department, a lot of the big companies now really don't relate to their exploration teams. They have no idea who they are. They're just a number on a payroll. In Ivanhoe, we never had that. We knew all of our exploration members personally, and they could come to us at any stage, perhaps with a personal issue that they needed to deal with, or something that they felt strongly about needed to be done, and also education and training, critical aspects for successful teams. Big companies have tactics and strategy, but what actually works is culture and teamwork, and I alluded to that on Sunday. So that's the main key factor I see that really works and how things get done. You have to be flexible, you have to have a strong culture, and you have to have teamwork and people that you work together with and rely on. I think I showed this slide earlier. Diversity is critically important in teamwork. We come now to exploration models. Most geologists and companies use models, some more so than others. The model section in the center is Dick Silito's model about porphyry copper type deposits and associated deposits. This is his more recent version. It's very good, and it is a useful model. The early porphyry models back in the 1970s were based on porphyry copper deposits in the southwest US, which work fine for the southwest US, but they had almost no application elsewhere, i.e. Southeast Asia the Western Pacific, and the Chilean Andes. Eventually, models were developed for, in this case, the Andes, which was very different to the model I just showed you. And then came later a more broader regional view about models and porphyries and how other types of deposits relate to these porphyries. And some of the deposits in Myanmar we can plug into this, particularly the distal disseminated and jasperoid deposits, such as you have around Chakpato. We have skarns, and we have the Lepidong intrusion-related copper system. This has been refined in more recent years by including on the spatial distribution of the deposits, we input alteration and vein types, and then furthermore, distal alteration assemblages allowing us to vector into the porphyry. So with time, these models are advancing in a very positive sense. However, they are still only broad guides. And one of the more recent ones is what's known as basically the Pathfinder trace elements, which is actually, I find, fairly academic, but it does have applications in some situations. The bottom line here is, and my message is, that always keep an open mind. Always expect the unexpected. You can have a model, but be prepared to amend it, change it, or absolutely change to something that's not in the model. And that's, by keeping an open mind, is how one may find the really big ones, and particularly elephants. I have a number of examples where there's been a model that was applied. The entire focus was looking for the model, and when some lateral thinking was applied, the actual big deposit was exactly the opposite to the model. It's a long-term business. One has to be well funded for a minimum period of 10 years. The reason for that is to override that cyclicity, which we saw earlier in the presentation. If a company has $3 million as a budget for 3 years, the chances of success are almost zero. So we have to have funding and the ability to outride those cycles, and those are the companies that will be successful. And here's an example. I may have mentioned this on Sunday, I'm not sure, but the world's highest grade, largest copper deposit is Kamoa-Kakula. That was found in 1995, and it finally went into production in 2022. 27 years. So with a $3 million budget and 3 years time frame, this would never have been found. Frederick Ransom was one of the founders of economic geology, the Society of Economic Geologists, an incredibly practical, talented geologist who found many deposits. And he basically said, we need to have good science, but it has to be practically applied in the field. So without the field work and the science behind it, the chances of finding something are very limited. Now, the closing remarks here. So successful exploration teams have to be motivated individuals led by a highly experienced manager who has technical and people skills. To get the funding for the exploration program and the trust, there has to be good communication with the chairperson and the board. This relates to funding and timeframes and a lot of autonomy. The exploration manager has to play a significant role in determining corporate health and safety policies. Otherwise, the ability to operate in the field is severely curtailed. And then I mentioned timeframes and budgets, because without that long-term, well-funded timeframe, the chances of finding or surviving the boom and busts are highly unlikely. Just to wrap up, some things that I've found practically useful in the field. What we're looking at here is a white rock. What is it? Could be anything. We don't really know. If we take this rock and cut it with a diamond saw, we then see, and this is the same rock, we can see that it's a beautiful coliform adularia quartz banded epithermal vein, and this is high-grade ore from the Sleeper Gold Mine in Nevada. Here's another weathered outcrop. This is from a gold deposit in northeast Mindanao, Tambas in the Philippines. And just by looking at this, we can't really tell a lot about what it is. take a piece of this rock, cut it with a diamond saw, and all of a sudden we can start looking at this and describing what we see. What do we see? We see very rounded clasts of different size and composition. We see a very high matrix to clast ratio, and we can see that it's had sulfides. And so one interpretation of this, just based on the observations, is that this might be a diatreme breccia. If we go back to that, we can't see a great deal, but by cutting it, we see so much more. This is what has been applied in all of Ivanhoe's exploration camps. And we actually did this at Moditong. For those of you that remember the office down in the town, we had cut slabs. But if you don't have access to a diamond saw, here's the poor man's diamond saw. It could be applied in the Wunto Massif. It could be applied in the jungles of Colombia. It could be applied in Central Asia in a remote area. All of the local people typically have bush knives, and to sharpen their bush knives, they have grindstones, like illustrated on the left. So if you take a rock sample in the field, you look for the flattest side of the rock, and then you take your marking pen and you put a big X on the flattest side of that rock. You've then collected 20 or 30 rocks from your field program. You've marked them all with an X, and you go down to the local village and you talk to the person in charge, and you would like to hire a group of people to grind the rock surface until there's no more X. Once that X is gone, you've got a beautiful flat surface to look at the textures of your rock, styles of mineralization, and make your interpretations. This is a very valuable, simple thing to do, and I've found it and still find it to be a very effective, simple thing to do in the field. Ivanhoe's exploration base in central Mongolia, we were fortunate to have a diamond saw, and over a period of years and several tens of millions of dollars exploration, we had a very good record of what we called a slab library of all of the things that we'd visited. We had all of the assays of these rocks, and it was a very valuable database. The first time I came across this was when I was working for an American company called AMAX, and at the Henderson mine in Colorado, they had already established this in the 1970s, and it's always stuck in the back of my mind. And I was very pleased to see that last year when I revisited this, the library was still there, was still fully intact, incredibly valuable. Other examples from an exploration program in South Korea that Ivanhoe was doing, we slabbed all of the rocks, and then once we had the assay sheet shown down there in the bottom right, we could tell where the high grade samples were, and most importantly, which textures had the high grade. So yet again, a very useful exercise. In summary, the right team, the right place, minimum bureaucracy. In other words, the exploration manager makes all the decisions and trusts the team. The team is trusted by the board. No micromanagement, complete management support, and well funded for 10 years. I think that finally concludes our session. It's been a pleasure to present to you all. I hope that you've enjoyed it as much as I have. And now we have some time for questions if you have. Thank you very much.